Bismillahirrahmanirrahim. Assalamu alaikum. This is your teacher Saad with first lesson of physics for class 10, and this is basically the summary of the lesson you took earlier online. First of all, this is the third Ashra of Ramadan, and the Prophet sallallahu alaihi wasallam taught us this dua to recite during last Ashra, which is Allahumma ajirni minan nar. So I request my students to recite this dua as frequently as they can in the last Ashra, and it means, "Oh Allah, save me from the hellfire." And during this last Ashra, there are odd numbered nights for which the Prophet ﷺ had predicted that there is a possibility of Laylatul Qadr to be lying in these odd numbered nights. So Prophet ﷺ taught us this dua for Laylatul Qadr, which is Allahumma innaka afun kareem tuhibbun afwa fa'afu anni. O Allah, certainly you are most forgiving, you love to forgive, so forgive me. This is the book that we'll be following during class 10, inshallah. The first topic is simple harmonic motion. You've studied many types of motions in class 9, like translatory motion, rectilinear motion, vibratory motion, and rotatory motion. Simple harmonic motion is a special type of vibratory or oscillatory motion in which A is proportional to minus x. And this is the condition that we'll prove later on. A is acceleration and x is displacement. So we can say that acceleration is directly proportional to the negative of displacement in this type of vibratory motion. So a simple harmonic motion is merely a vibratory motion which satisfies this condition. Vibratory motion is what you studied in class 9. It is a motion in which an object is displaced from its fixed position and is made to move to and fro periodically. So the to and fro motion of a body about a mean position is known as vibratory motion. These are some examples of vibratory motion. For example, simple pendulum, which is able to oscillate about a fixed mean position. A thread which is fixed between 2 points and is plucked and released, it produces vibratory motion. And similarly, a spring with which a weight is hung and it is plucked vertically and released, it will produce vertical oscillatory motion. Now, one thing you have to keep in mind that in theoretical physics at your level, in secondary and higher secondary levels, we consider that the place where this oscillation is taking place has no losses. It has no friction, no air resistance, and the threads and the springs, they are weightless. And in some of the cases, for example, in the rightward case and the case in the middle, the thread and the spring, in thread there is no gravity, but for pendulum, simple pendulum, and for the weight connected with spring, we consider that there is gravity. So the only cases in which gravity is causing motion, we consider gravity to be there, but for other cases in which gravity is not causing the motion, we consider that gravity is a loss and we consider that there is no gravity. So this is the system of horizontal system of a mass attached to a spring, which is able to move freely horizontally on a frictionless surface, and we consider that there's vacuum, there's no air resistance, there's nothing that can stop it, and the spring is weightless. And if these conditions are met, which is not possible, but we consider it theoretically, it will continue to oscillate horizontally forever. And this is how it will oscillate. In the first figure, the topmost, we see that the spring is plucked and the mass is moved to a rightward position. Since the spring has a property of elasticity that you've studied in class 9, it will pull the mass to regain its original shape. So in second figure, you see that the mass has reached its mean position from where it was moved. But because of inertia, it does not stop here and it continues to move until it compresses the spring. Now when it compresses the spring again tries to regain its original shape, and in fourth figure you see the spring pushes the mass and move it towards the mean position. Then again it doesn't stop here at inertia, because of inertia, so it moves rightwards, and then again the spring is plucked, and it the same these five phases of the motion continue to happen forever, and the mass continues to oscillate between the leftward and the rightward position, and at each time it passes through the mean position. This is how it happens practically. This spring is plucked and moved to an extreme position denoted by blue dotted line, and when it is released, it passes through blue dotted line. The original black dotted line is extreme position, the blue dotted line is mean position, and then the other black dotted line is extreme position. So it oscillates between two extreme positions denoted by black dotted lines, and at every vibration it passes through the point of blue dotted line, which is mean position. And something you have to keep in mind is that at extreme positions the potential energy is always maximum and kinetic energy is zero. Similarly, at the mean position the potential energy is zero and kinetic energy is maximum, and the total energy at all the points will remain same. But the potential energy is in this case is not the potential energy that you studied in class 9. That was mgh, that was gravitational potential energy. Here it is elastic potential energy. Similarly, for simple pendulum, it oscillates between two extreme positions, and each time it passes through a red dotted line, which is mean position. And similarly, as happened in the mass spring system, at extreme positions of the simple pendulum, the potential energy is maximum and kinetic energy is zero. Similarly, at mean position, kinetic energy is maximum and potential energy is zero. And here the potential energy is gravitational potential energy. There are some important terminologies that you have to remember. One vibration is the one complete round trip of a vibrating body. So if we notice the simple pendulum in the figure and we start noticing it now, it starts to vibrate and now it completes one vibration. So this one complete round trip is one vibration. Mean position, which is denoted by the red line, is the fixed position about which the body vibrates. Extreme positions are the two positions in which it is vibrating, which was denoted by black line in this figure. And here you see the pendulum is oscillating between, this is the extreme position and this is the extreme position. Amplitude is the maximum displacement of a vibrating body from mean position, or we can say that it is the distance between the mean position and extreme position. Time period is the time taken for one complete vibration. So if I start noticing the time, I'll start now and I'll end now. The time taken for this is one time period denoted by capital T. And frequency is the number of vibrations in 1 second, and it is not the unit of frequency is in hertz. So the number of times the pendulum vibrates in 1 second will be frequency. You might have seen frequencies on your audio devices written as 100 hertz or 200 hertz, which means the frequency of the sound being emitted by the audio device is 200 hertz. Or you can say that the sound wave is vibrating 200 times in 1 second.